Okay, so another type is sets. So um, you can create a set from a list, is the most common way, or you can create a set from a string and it will separate it out. It's kind of like making a list from a string. But what a set is a set of unique objects. So it's just like in math, you know, you have a set of objects. So if you have more than one of the same thing, that gets kind of ignored. It just creates one. You have let's see if I can show you an example. So here, even if I have the letter M 3 times, I'm still just getting that letter in my set once. So I can also make a list. And then in math, you know, you have intersections and unions. So the intersection would be the elements of those two sets that are found in both. So if you think of your Venn diagram, this would be the part that's in the middle. So the part that's shared, the intersection of those two sets is A and M. And the part that's not just shared but is in either of the sets is the union. So we use, instead of an and symbol for intersection, we use a bar for union. And the union gives us all the elements that are found in either of those sets. We can also do subtraction. So this is different than the kind of subtraction we've seen before. This is finding the difference in the sets. So if we take all the things in X minus what's in Y, so we're going to remove the H because it's here. We're going to remove the M, and I'm sorry, the A and the M, and the H doesn't matter because it's not in X. So X minus Y is going to give us just P and S left over. And that, again, we can check what kind of type that is. That's a set. One of the handy things with a set is if you want a quick way to get all of the unique elements in a list, you can change the list to a set, and that will remove all the redundant elements, and then you can convert it back to a list, and now you've got just the unique elements of your list. So that can be handy. Okay, we talked at the beginning about Boolean logic. So there's Boolean data type. So these are evaluating expressions. So we can say is 1 greater than 2 or is 1 less than 2? So false, true. And remember, as I said, when we just type expressions separated by commas, that's going to output a tuple. So the bool function will convert a number to a Boolean value. So 0 gets converted to a false, and 1 gets converted to a true. I'll see how that works. So any string will get converted to true, and any number that's not 0 will get converted to true also. So remember, we have this OR statement, so we can say true or false. It's going to evaluate as true. These implicitly, if we evaluate these logical statements as numbers, so we do false plus 1, we're going to get 1, because false, if you treat it like an integer, will evaluate as 0, and true, if you treat it like an integer, will evaluate as 2. This could have advantages in your code in certain areas. Same as if we say, is true equivalent to 1, it will say, yes, that's true, but if we do this identity operator, true is 1, it's going to identify as false. Same thing with false. It has the value 0, but it is not the same thing as 0. And again, this expression, any kind of Boolean expression, is type bool. There's another type that's doesn't really fit in anywhere else. It's called none type. And different parts of Python have different versions of this. NumPy has something called NaN or NaN or not a number. We'll see that's a little bit different than none. So if we evaluate this, nothing comes out. If we print it, it just says none. If we try to add something to it, we can't add anything to none type. But it still exists because some things have no value, and so we have that option or we just want to be aware that it exists. Finally, we have the type function. I've been using this all along, but it's very useful when you're trying to figure out what's going on in your code to know what kind of type you're dealing with. That tells you a lot about what it is. So we can say, what's this type of 1? Well, that should be an int, an integer. 1.0 is a float. 1 in quotes is a string. 1, 2 is a list. In brackets, if it's in a rounded, in parentheses, it's a tuple. If it's in curly braces, it's a dict. If it's in curly braces but not with this colon, so yeah, the important thing is that this is a key value pair here, whereas this is a set. And we have true, false, and type. Now I should check, because I told you that this was an empty dict, and it is. So this will not give you an empty set. If you want an empty set, you can do this. So yeah, there's a little ambiguity there, but it should be obvious from the context if it's a set or if it's a dictionary, based on how it's written here. So that's the type function. That's really useful to figuring out what kind of data type you have. And we've covered now the major data types in Python, the core data types. We will cover a lot more. We'll cover things like NumPy arrays, pandas series, and pandas data frames. Those are actually the 3 main data types that we're going to be using in the class. But those are built on top of these things that we've already talked about, and they work in a lot of the same ways, but they have other methods and other properties. So it's good to know how to use all of them. And so that's it for lesson 7. And if you have questions, let me know.